All right, so we're solving multi-step equations and we're at these last four problems. So based on what we were just doing, you ought to be able to do number 9 and 10, but I'll warn you something strange is going to happen, and I want to see if you can interpret the answer correctly as a result. And then on 11 and 12, if you think you know how to solve an equation like that with fractions, I would encourage you to do that. Now keep in mind, when I do it, I'm going to clear fractions, which means after one step, basically multiplying both sides of the equation by the LCD, the fractions are going to be gone. All right, so go ahead and give them a shot and then watch the video. All right, so on number 9, now keep in mind I'm using this approach, the CSI 1 and 2 step, and so I'm sorry, I didn't mean to do that step yet. C stands for clear fractions, so we don't have to worry about that with 9 and 10. S is for simplify. Well, notice there's nothing to simplify on either side. But we do have to use the I, or we have to isolate M on one side because it's on both. So we'll subtract 6M on both sides, and something strange happens. We get negative 12 is equal to 18. Well, that's a false statement. And in fact, so what does that mean the actual solution is? We're solving an equation. Well, anytime you get a false statement, that means there's no solution. In other words, there's no value of M that would ever make these two sides equal. The other way we can write no solution is using the empty set notation. All right, let's move on to number 10. Now, if you look at the left side, it's perfectly fine. It's simplified. Nothing I can do there. But we do need to do some simplifying on the right. We'll distribute. We get 2x minus 10. And then don't forget the plus 5x. Notice you're not distributing times the 5x. And so now we're still not quite done on the right. We've got those x terms. 2x and 5x is 7x. And so we'll get 7x minus 10. Now again, if you look closely here, notice the 7x's on each side, but also the minus 10's. In fact, I'm going to change the order just so you can see how obvious it is. 7x minus 10 is equal to 7x minus 10. Well, isn't that going to be true no matter what x is? So what's my solution? This is actually sometimes called an identity. It's true no matter what x is. Well, the solution is all real numbers, which are all the numbers we work with when we're solving equations. And we sometimes will write all real numbers this way. It's like a capital R with two legs. Now the other thing I'll mention here is I could add 10 to both sides and subtract 7x on both sides, and you'd get 0 equals 0, which essentially means everything fell out. And that's only going to happen when the two sides are equivalent or equal. All right, so let's move on to fractions. So on number 11, there's only one denominator, so our LCD is going to be that denominator, 3. And so remember what we're going to do. We're going to multiply both sides of the equation by 3. Now, don't write this down, but I want you to watch. So I'm going to multiply the left side by 3, and I'm going to multiply the right side by 3. But keep in mind there's two terms on the left, so we're going to have to multiply 3 times each of those terms. All right, and so that's basically what we're doing. When we do this, when we clear fractions, we're going to end up multiplying each term by the LCD. All right, so let me erase this, and let's do that. This is the way that I would prefer you show your work. So you're going to multiply each term by 3. So when we multiply 3 times negative 7/3, the 3's are going to cancel. If you want, you could put a 1 here. And 1 times a negative 7x is negative 7x. Next, we're going to multiply 3 times 1/3. Well, the 3's cancel. You're left with 1 times 1, or just 1. And so we're going to get plus 1. Now, hopefully when you look at 3 times the third, you recall, hey, we're multiplying reciprocals, and when you multiply reciprocals, you always get 1. All right, on the other side, we're going to get negative 27. So notice if we just multiply each side by 3, the LCD of the denominators, we cleared the fractions. The fractions have gone. They've disappeared. This is a great thing. All right, so now we have a two-step equation. So again, if you think back to CSI, we've cleared fractions. We don't have any simplifying to do. And i's for isolate, we don't have x on both sides. In fact, we can see as soon as we clear fractions, we have a two-step equation. So all we've got to do is subtract 1 on both sides. We get negative 7x equals negative 28. And then you can divide each side by negative 7, but that's going to be 4. All right, so I would encourage you to try number 12. Now, you may want to wait till we make sure we have the LCD right. So think about what the LCD would be here, and then I'll tell you in a sec. All right, so basically we're finding the least common denominator of for our denominators. All right, so what we're really looking for is the LCM, or least common multiple, of 4 and 12. What does that mean? Well, the multiples of 4 are 4, 8, 12, 16, and so on. And the multiples of 12 are 12, 24, and so on. And you can see that 12 is the smallest common multiple. Now 24 would be another that works. But we want to use the smallest number possible because we're going to be multiplying each term by this number. So let's go ahead. So our LCD is 12. We're going to multiply each of our terms by 12. So let's see. When we multiply 12 times 3/4, 12 divided by 4 is 3. And 3 times 3x, well, that's going to be 9x. And then we have 12 times 7/12. Well, 12 divided by 12 is 1. And we have a minus 1 times 7x. That's minus 7x. And on the other side, you get negative 60. And so we're going to get 2x is equal to negative 60, or x equals negative 30. Now, I want to go back and show you there's another thing you can do on number 12 here to clear fractions if you were struggling seeing what I was doing here. So basically, we had 12 times 3/4 x. And so we could actually write that as 12 over 1 and just multiply across. We get 36 over 4x, which is 9x. So that's kind of the long way to do it, but we still get the 9x that we got here. And if you do 12 over 1 times 7/12, now you can certainly cancel the 12s here. Otherwise, you're getting 84 over 12. And if you divide that, you get 7. And so be careful, though, because it's a minus 7x. All I did was multiply 12 and 7/12, but you actually have actually, I guess I could put the x in here. And so this is 7x, but we do have that minus out front, so it doesn't have to be a minus 7x. All right, so if it helps, you can do your work off to the side, but the most important thing is that you can, once you've identified that LCD, is that you can use it correctly to clear the fractions. You know, it takes a little bit of getting used to this technique, but you're going to find this is a really slick technique as we're going to do several problems throughout the course. And in some cases, we're going to get into some more complex types of problems. Clearing fractions is going to be our best bet. All right, so that's it for this second video on solving multi-step equations.